All right, so the first question we're asked is, what is the limiting reactant when 82 grams of copper reacts with 25 grams of sulfur? And so, yeah, go ahead. Okay, so what makes you think that?
Because 25 grams of it is less than, is that half of it? Because there are two copper for every.
Okay, so that's a good thought process, that we're starting with less than half. Based on our mole ratio, we might need twice as much sulfur as we do copper. But the issue is copper and sulfur don't weigh the same, do they? So 1 mole of copper weighs 63 grams, 1 mole of sulfur only weighs 32. So you can't just look at it and figure out based on its starting amount which one's going to be my limiting reactant. Okay? You're going to have to actually do the math. But that is the good thought process. For molecules that weighed the same or similar, we might be able to use that thought process. But until we know that a little bit better, we've got to go through the actual process. So what's the limiting reactant when 82 grams of copper reacts with 25 grams of sulfur? The second part of the question says, what's the maximum amount of copper sulfide that could be formed? Okay, what's the maximum amount of copper sulfide that could be formed? So, essentially what we need to investigate here is, based on the starting amount of each of our reactants, 25 grams of sulfur and 82 grams of copper, we want to know how much of our product can we make, right? That's the goal. How much of our product can we make? We don't put these both starting values into the same T-chart. We just have to do 2 charts. We have to investigate, if we used up all 82 grams of copper, how much copper sulfide could we make? And then we do another chart to see, if we used up all 25 grams of sulfur, how much copper sulfide could we make? And then we compare those values to see, where is our production going to be stopped? Which of our reactants is going to limit that production? Okay? Essentially, when we do limiting reactant problems, we have to do them twice. We do a chart from each of our reactants to the same product. Okay? In this case, there's only one product, so we really have one choice that we go to. If there were multiple products, we would pick the same product and take both of our reactants to that product to be able to compare. Okay, and I'll kind of explain that as we go on. But let's go ahead and go through the math here. Okay, we've got to feel pretty good about T-charts so far, so we're going to go kind of quick here. 82 grams of copper to grams of copper sulfide. Start with what we know. We're going to get rid of grams of copper, go to moles of copper. Moles there gets the 1. Grams of copper is 63.5. I'm just going to leave it there. 63.5 grams. We're going to get rid of moles of copper and go to what? Moles of copper sulfide. Then we're going to finish by going moles of copper sulfide to grams of copper sulfide. Okay? In my roll ratio step, I'm going to pull those numbers directly from the balanced reaction, which means copper is going to get a 2 and copper sulfide is going to get a 1. And then back to moles getting the 1 here. Copper sulfide's molar mass, 95.5. That can't, I think it needs to be bigger than that. Maybe 159. Is that what you had with 2 coppers plus a sulfur? I think comes out at 159. Okay, so here's the math. We're going to go ahead and do the math that goes with that. 82 times 159 divided by 63.5 divided by 2. This gives me a total of 102.7 grams of copper sulfide. Okay, now this is just one option. What this tells us is that in my reaction, if I used up all 82 grams of copper, I would have the possibility of forming 102.7 grams of copper sulfide. right? That's what our conversions and our charts tell us. If we use up all of our reactant, all 82 grams of that, we have the possibility of forming 102.7 grams of copper sulfide. Okay? So let's do it with our other reactant, 25 grams of sulfur. Still going to go gram to gram here. So grams of sulfur to moles of sulfur. Molar mass for sulfur is just 32. Moles of sulfur to moles of copper sulfide, Cu2S. We're taking them both to the same product because we want to be able to truly compare which reactant will allow us to make more or less product, right? But it's got to be of the same product. You can't compare them to two different things. So copper sulfide gets a 1, sulfur gets a 1, and then we're going to go moles of Cu2S to grams of copper sulfide. The good thing about these ones that you already did calculate the molar mass for copper sulfide already, right? It's 159. Okay, so now I'm going to run the math with that. 25 times 159 divided by 32 gives me a possibility of forming 124.2 grams of copper sulfide.
So copper is the limiting reactant?
Right, that's exactly right. So Lauren thinks copper is the limiting reactant. That's correct. Do we understand why?
Because it can only produce 102.7.
Right. The amount of copper that we started with only allows us to form 102.7 grams of my product, which means I'll never get the opportunity to form all 124 grams that the sulfur has the potential for.
If you subtracted 102.7 by 124.2, would that be the leftover sulfur?
No, because you would convert differently with moles, right? So you could find out how many moles of sulfur are left over and then convert that to grams based on the sulfur's molar mass, but you couldn't just subtract it like that. That's a good thought, but no. Okay? What questions do we have about this concept? Yeah, Faith. Yeah, it's exactly right. We're going to look for the lesser amount of product because that's been limited, right? That's the limited amount of product that I can make. And so when it asks for the limiting reactant, I need to go back and look at what reactant did that come from. A lot of you will just do this. Oh, this is my limiting reactant. Well, no, it's not because copper sulfide is a product. It's not a reactant. When you answer the question about limiting reactant, you've got to go back and see what reactant did I actually come from and say my limiting reactant is copper, right? Rewrite it or go back and circle it. But a lot of you will just try to do this. You'll say, oh, here's my limiting reactant. It's a smaller number. Well, that's not true because copper sulfide is not a reactant. It's a product. So you check the T-chart that gets the smaller amount of product, but you've got to go back and look at, well, what reactant did I start with? And that's my limiting reactant. So to answer this question fully, we would say copper is our limiting reactant. And then what's the maximum amount of Cu2S that could be formed? What is it?
100.7.
Yeah, it's 102.7. It's tempting for us to say, well, the maximum amount's 124. But the truth is that we won't get the opportunity to form that much because we'll run out of copper at 102.7 grams. Okay? So this is the max amount of copper sulfide that could be formed. Okay? So this T-chart then really becomes kind of like moot, right? We did it to prove our point, but then we're not using that one anymore. Okay? And then if it asked us to solve more problems after that, you would always start with your limiting reactant again. So once you know what your limiting reactant is, that would be the start of any other problem you would have to do. You'd always start with your limiting reactant value. Okay,
If there were 3 different elements?
you would have to have 3 different ones to figure out which one is limiting. But I won't give you any of them. Yeah. If there were multiple products, like I said, you'd get to pick the product you take both charts to. And then if it asked you what's the mass of the other product, you would just go limiting reactant to your second product. Okay, I know that's kind of confusing right now, but we'll look at one. Okay. All right, so this kind of explains what we had to do. We had to do the problem twice to find out which was the limiting reactant. We looked at gram to gram, and I gave us some space to do that, but we already did that. Okay. Since the limiting reactant is copper, we use that to determine how much product is produced. The amount of copper we initially start with limits the amount of product we could make, right? We had, which one of our reactants here was in excess then?
Sulfur.
It had to have been sulfur, right? Copper was our limiting reactant, so sulfur had to be our excess reactant. All right, here's another reaction, and then here is the question that goes along with it. What's the limiting reactant when 6 grams of HCl reacts with 5 grams of magnesium? All right, so go ahead and get written down what you need to with the reaction and the question, and then we'll start this one together. All right, so the thing that's a little different about this question is that we have multiple products, right? We start with 6 grams and 5 grams, but we have 2 different products, and it doesn't ask us a specific question about a specific product, does it? It does not ask us anything in particular about H2 or MgCl2.
So do we have to make 4?
No, that's a good question. To find the limiting reactant, I just pick a product and take both of my reactants to the same product. So if I was going to pick a product based on this reaction, which one would I probably pick? I would pick H2, right? Why would I pick H2? The molar mass is extremely simple, right? It's less room for error there, right? I'm just probably not going to make a mistake on that molar mass, okay? So that's the simplest reason. If I'm going to pick a product, I just try to pick the one that has a simpler molar mass, okay? I think our reaction is balanced here. Let's just double check. I've got 2 hydrogens, 2 chlorines. All right. So let's go ahead and start with our mass of HCl. I'm going to start with what I know, 6 grams of HCl. And we said our goal was going to be, just because we got to choose the product, we're going to compare to H2. Okay? With limiting reactant problems, I do want to tell you, look ahead. You know, if a problem has A, B, C, whatever, and it asks you about percent yield of H2 in part C, make sure you're reading that ahead of time so you don't waste time, right? Go to H2 the first time. So just make sure you kind of read your problems ahead, but it doesn't ask us that in this case. We're going to go grams of HCl to moles. HCl, that would be 36.5 moles of HCl to moles of H2. Looks like that's a 1 and a 2. And then moles of H2 to grams of H2, so 2. Okay, so multiply across the whole top, divide by the whole bottom. I get a value of 0.164 grams. Is that about what you had? Anyone that did the problem? Yes?
What did you say?
I got about 0.164 grams of H2. No?
I got point.
No, we still don't know anything yet, right? We've got half of our information. We don't know everything yet. Yeah. Right, I choose this product to go to? Okay, it didn't tell us, it didn't ask a specific question about a product. It might have said, how many grams of MgCl2 could we form? But it didn't. So I got to pick the product I went to. The only reason I picked H2 is because its molar mass is really easy to calculate. That's it. Right? I could have picked either one, and I would have got the exact same limiting reactant. So if HCl happens to be the limiting reactant based on the information for H2, it will also be the limiting reactant if you would have chosen the other product. So it doesn't matter which one you go to. Okay, if we look at our grams of magnesium, magnesium's molar mass is 24.3, 1 mole magnesium to 1 mole H2. And then 1 mole H2 to 2 grams. And so that means I get a value of 0.411. Yeah, 0.412 probably, you're right. Okay. Approximately 0.4 something grams.
Yep.
Is that about what we had when we ran the numbers on those? So tell me which of my reactants is the limiting reactant. Right. It comes from the smaller amount of product formed. So that means I go back at my T-chart and I say, what reactant did I start with? And that means my limiting reactant equals HCl. Okay, I check to see what is the what reactant is actually limiting my production, right? Based on magnesium starting amount, I could have made 0.4, but I'm not going to get that opportunity because I'm going to run out of HCl first. Okay, so do you see how it's not as easy as just looking at which is the smaller starting amount, right? 5 grams of magnesium is less than 6 grams of hydrochloric acid, but HCl is still a limiting reactant. So there's a lot more that goes into that. And vice versa, it's not always going to be the bigger starting amount is the limiting reactant either. We've seen that both times, but there's not a pattern with that. You can't base your answers off of the starting amounts. They just give you a place to start from. That's it. Okay? If ethylene is combusted with a 3.25 grams of oxygen, what do you think you can do that one yourself? Can you write the reaction for a combustion reaction? What do we know? Okay, walk me through it. C2H4 is one of my reactants. What is it reacting with? Oxygen, but it's not just O, it's O2 because it's a diatomic. And then what are the products of a combustion reaction? CO2. There we go. So you guys could have done that. Okay, so if you balance it, let's see, 2. Let's try 2. So that's, I think that should be balanced. 2 carbon, 2 carbon, 4 hydrogen, 4 hydrogen, 2 plus 4, 6 oxygens. I think that's balanced.
Well, so far.
All right, let's go ahead and try this one on your own. You're starting with 4.95 grams of that, 3.25 grams of oxygen, which is O2. What is my limiting reactant, and how many grams of carbon dioxide could be formed? So which product do you think you should pick? I think you should pick carbon dioxide because it asks a specific question about carbon dioxide. So don't waste your time going to H2O and then have to do another chart to talk about carbon dioxide. Just take both of them to carbon dioxide the first time. Okay? I'm going to give you a couple minutes head start and then I'll start on it here on the board. So there's what I had for my kind of base information. Is that what you had as the result of both of your T-charts? Roughly 15.56 grams based on C2H4 and then 2.98 grams based on O2. So let's walk through actually answering the questions. Which is my limiting reactant? Limiting reactant is, let's everybody say that with some confidence. O2, good, yes. Okay, O2, because it only allowed me to make 2.98 grams of my product. And so when it says how many grams of carbon dioxide can be formed, which I can't just say both of those because one of them is not even possible. So how many grams of CO2 can I actually form? 2.98. That's it. So then I just circle that answer as my ability to form CO2 grams, right? This one I'll never get to that point. Whoops. I'll never get to the point to be able to form that. Okay, so it's not going to be an answer, an option for me. Okay? All right, what if it had asked me, and you're going to see some of this on future homework, what if it had asked me, what is the mass of each product? What's the mass of each product? Do I need to do 2 more charts to figure out the mass of H2O? Right, I know that oxygen is limiting my reaction. I know that that's true. So I only have to do 1 more chart from oxygen gas to water. Right? I only have to do 1 more thing to solve because I know my limiting reactant. And once I know my limiting reactant, every future calculation I do starts with that one. Okay? So if it asked for mass of each product, I would do 2 to figure out my limiting reactant, and then I do 1 additional one from my limiting reactant to my other product. Right? Does that kind of make sense? If that were the case. All right, last one here. I want to combine it now with percent yield. Okay, so you've got a reaction listed up top. Is that big enough in the back, or do you want me to make it a little bit bigger?